Properties of natural logarithms. Notice that our properties are pretty similar or identical than the log properties. So not a huge difference between them other than we are using base e, so we call them ln instead. Logarithm of 1, if you have ln of 1, well, by definition, is 0. The only thing that can give you a 1 would be a 0. Logarithm of the same base, ln of e, keep in mind, ln is base e, log base e, so they cancel each other out, giving you a 1. When you multiply and divide by the same number, it gives you 1. So that's just a reference, so be aware of that. In this case, ln and e are opposites to each other, cancel out, giving you a 1. Power property, so ln of x to the p is equivalent to, say, p times the ln of x. In other words, a log, in this case natural log, allows you to bring down an exponent, so it still applies. Or you can also bring it back up, be aware of that. Product property is similar, once again, when you're adding and they have the same base, in this case base ln, you can add what's in the parentheses in a single natural log, so ln of x plus, or pardon me, x times y. Quotient property, likewise similar, ln of x minus ln of y, since both bases are the same, we can combine into a single parentheses and one single log, or in this case natural log, ln of x divided by y. So let's try some examples to see if it makes a little more sense. So let's once again just write at the top of our page our basic formulas, conversion formulas. Ln of a equals k, and once again e to the c equals a. Pardon me, that k should have been a c, so be aware of that. That k should be a c. Okay, so a, ln of 2x plus ln of 5x equals 4. So in this case, it looks like we can use what property? It's addition, right? So it looks like we can use the product property because it becomes from addition, it converts into a multiplication. And it looks like the one that follows is a subtraction, so we can use a quotient property. Alright, so in that case, let's combine into a single ln, and we're multiplying what's inside the parentheses, 2x times 5x. So 2 times 5 gives us 10, x times x gives us x squared, agreed? So ln of 10x squared then equals 4. So once again, 2 times 5 gives us the 10, and x times x gave us the x squared. Okay, so likewise, we can convert. So from here, we want to convert. There's nothing on the outside, so we want to convert it. Basis ln is reference to e, right? So we're converting to e to the c. In this case, the c value, or k value, depending on how you choose to call it, right? We've seen it as both k and c. That's why I kind of have it written up at the top mixed up with the k and the c. I'll fix it in a minute, though. So 4 is our c value or k value in this case, so it's e to the 4th equals 10x squared, agreed? And now let's get rid of the 10 via division. So let's divide by 10 on both sides, cancel the 10 on the right side, and now we have e to the 4th divided by 10. So that's a number that can come out of our calculator. So real quick for reference, our calculators, turn on your calculators, clear anything that you might have. The E button, once again, if you push second and the ln button right below the log button on the left side, you should see an ln button. It'll give you an E, so you have to push second and ln to get the E. So E, we're going to put a 4, close our parentheses, and divide by 10. Once we divide by 10, it should give us the number. So it's 5.459815003. I would round it probably to the second decimal at least. 5.46, just as a reference. Or you can go at 5.5. Okay, so 5.46 as I mentioned before. And now let's get rid of the exponent of 2. So that could be through x square root or exponential root, agreed? So something to be aware in case you've noticed in the past. I may have missed it. Every single even number root would give you a plus or minus, so be aware of that. So in this case, we have to do the exponential root on both sides to get rid of the exponent of 2. And the 2 times 1/2 are opposite and equivalent, so they cancel each other out. Keep in mind, you're welcome to put a 1 underneath that 2. That way you can see that they cancel each other out. 1 will be 2 over 1 times 1 over 2. And that's how they cancel out. Alright, so 5.46 to the 1/2. So we previously entered that in a calculator, right? Or at least the e to the 4th divided by 10. So we have the answer still on our calculator. So now if you push the caret key, it takes the previous answer and raises it to the exponent. So exponent, parentheses, open parentheses, 1 divided by 2. Or square root, in other words. You could also use the square root, but it makes it easier this way. If you push the caret key, gives you the answer, caret key, 1 divided by 2. Don't forget to close your parentheses. In other words, remember, close your parentheses, hit enter, and it gives us 2.3366. So there is our answer then. In this case, roughly 2.34 if we round it is our x value. So let's try the next problem, B. We have in this case 2 ln of x to the 3rd minus ln of 8x to the 5th, which equals 1. So do realize, a log allows us to bring down properties, exponents, which can also allow us to bring a log up. Natural logs are no different than logs. So therefore, ln, or natural logs, will also allow us to bring up the exponents or bring them down. In this case, I would rather bring up the 2, because if I try dividing by 2, I would still have a division by 2 in the negative ln area. So I don't want to have to deal with fractions. Instead, I'll bring it back up. So raising it up then, we have ln of x to the 3rd raised to the power of 2 now, minus ln of 8x to the 5th equals 1. So ln of x to the 3rd, 3 times 2 equals the power over power, agreed? So you distribute in the exponent. So 3 times 2 gives us 6. So we have ln of 6 minus ln of 8x to the 5th equals 1. And now, since it's a subtraction, that implies that we are dividing, right? We previously saw that. It's our quotient rule from our previous view. Here we go, right there. Very bottom, quotient rule. If we are subtracting, we take the first one divided by the second one and unite it with a single natural log, ln, on the outside. So let's go ahead and take what we just got and unite it into a single natural log with x to the 6th on top divided by 8x to the 5th on the bottom. And now let's remember, or let's note, that for exponents, when you're dividing, the exponents subtract, right? So it's x to the 6th over x to the 5th, or 6 minus 5. 6 minus 5 will give us an exponent of 1, or just x. So keep that in mind, agreed? So once again, that's just for reference. So ln of what we have left, x on top because it's a regular x, over 8. The other x's cancel. Keep in mind, you can expand this and have 6 x's on top of 8 times 5 x's on the bottom. And you'll notice that 5 of them cancel from the top and bottom. You're left with 1 on the top, 1 of the x's. So now let's convert this. So we want to convert this. It becomes e, since it's base e, it's ln, right? Base e. So e to the power of 1, because that's on the other side of our equal sign there. So e to the 1 equals x divided by 8. And now we can solve for x by getting rid of the 8. It's dividing because it's a fraction. So opposite of division, you guessed it, multiplication. So we multiply to both sides of the equal sign. So 8 divided by 8 on the right side cancels out, and that leaves us with 8 times e to the 1. Well, we can try that on a calculator, agreed? So let's try on our calculator. Once again, I'll clear this for reference, so it's easier to read. 8, and now you can either put a multiplication sign or assume that it's going to multiply. So second, ln will give me the e button, and we'll put a 1, close our parentheses, and hit enter. There we go, 2175 roughly. Let's double check this. So if I have 8 times second, ln will give me the e button, should give me the same answer. So it already takes, your calculator already takes into implication of multiplication there at the beginning. So it should give you the same value. So once again, it assumes that you're multiplying when you have a number next to the e button or the e function. So once again, let's copy down our answer here, which we got roughly 21.75. 21.75 is our x value, in this case our solution. Alright, let's finally notice that I've updated, in this case, the k value to c instead. So once again, it's at the very top, ln of a is a c rather than a k, so be aware of that.